I will speak about something that has a horrible name, multilevel regression and post-stratification techniques. But that is something that it's a concept that I'm really excited about, and I think it has huge implications on the sampling industry, how it works, on its future, and I'll explain to you why. Who's you said you're on the kind of supply side. Who's from a panel company or the research side of things? Anyone here? You are? This is an email that we get dozens of times every day. Right. So it says, we still need 3 women who are 50 years old from that country, right? Yeah, please get us them. We still need 10 young people who live in this and that city. Can you get them? Why do we receive these emails? We receive these emails because the industry is building quotas, because there's no random sampling, so they build quotas to get a representative picture of whatever population it has in mind. Right? So whether it's beer drinkers, whether it's the general population, or whatever. You build quotas to make sure that you cover your main demographics. One of our most exciting projects is a tracking study that tracks political risk in Mexico, in Venezuela, in Brazil, in Egypt, in Turkey, and in the Ukraine. So we assess, for example, how likely people are to demonstrate, whether they are worried about corruption, and all of these things. So why do I mention these countries? I mention these countries in this project because whatever is difficult in the normal big countries is crazily complex in these countries. It's very difficult to reach people, and you still want to have a good representative kind of sample to make sense out of the data, but it's just very difficult. This is from Venezuela, and it shows you some of the bias in our own access to people in Venezuela, right? So the people that we reach are more educated, younger, and more male than the census population in that country. Now we set up a quota size, and this is how it looks. It's cross quota, right? And this one, the low educated women of a certain age, these are really difficult for us to get in Venezuela. And some other groups are also very difficult to us. Now, the outcome of this is that field work for us looks like this. We get lots of people in the first few days, and then it takes forever to get the difficult ones. And anyone who works in research realizes this is not just Venezuela or a specific country. This is pretty much a standard project. Maybe not that extreme, but this is how the fieldwork usually looks like. Now, when you see this, you ask yourself, okay, how can we change this, right? How can we make it more efficient? Like you can say, okay, just get more people of these groups, but sometimes it's really hard to get them, right? So we've come across a super interesting paper that I recommend everyone read. And what the authors did was, before the 2012 presidential election, they asked a whole bunch of Xbox users to say who they vote for. Obama or who was it in 2012? Romney? Yeah, Obama, Romney. And this was a hugely biased sample, right? 90% men, all young, gamers, crazily biased. But what they then did was they employed this technique called multilevel regression and post-stratification. And what they managed to do out of this completely biased sample, to replicate a poll of polls of regular random sampling that predicted the winner of the presidential elections very accurately. So this is something that really excited us, and we said, okay, how can we use it for our own purposes? And I want to, bear with me, I want to explain briefly how the methodology works. It's quite exciting. So, the ideal case. the ideal world, right? You have these quarter cells and you fill them all. Everyone's happy. Everything's nice. The reality is that there are some cells that are very difficult to fill. And then you can't fill. And what you then do, essentially, is you weight it and you take the average. And sometimes, the fewer people you have, the more outliers you have, and the data in the end is bad, right? If you weight then these 5 people, take the average and weight it up, there's some variation then in your results that you don't want to have. Now, what multi-level regression and post-stratification does is that it builds a model. It doesn't look at the answers only in those cells, but it uses the strength of neighboring cells, meaning similar demographics, and builds a model on how this specific group would respond. So it builds hypothetical responses, if you will. So we did this with our data set on political risk, and we took one answer out of it, which is, have you experienced corruption in the last 12 months? This is one of the lots of questions that we ask. And the answer is 42% over the whole set. So we said, okay, we have these 42%. Now, really, we don't care that much whether it's 42, 41, 43. What's important for us is that it's in the 40s, or whether it's in the 20s, or whether it's in the 60s. So we said, let's put kind of like a maximum variation of 1 percentage point, up and below. How much does that change the way we sample? So if we say, okay, it's fine if there's some variation, how much time and money can we save in the sample setup? And when we did this, it was crazy, right? So we reduced the time it took to reach these people, to get meaningful results, by 98%. We cut it from over 2 weeks to 7 hours. So within 7 hours, we got a result using this. It's pretty much not the same, but almost the same for all practical purposes than the original baseline that we set. We saved over half of sampling costs, and we cut down the overall size by 1/2. So we then we said, okay, let's play a bit more. Let's go for plus minus 2%. We saved another 300 people, another additional cost savings of 8%, and 30 minutes saving 3%. This point where you get okay, we can do it, not have to do it. And then we said, okay, 5%, and a few less, bit more cost saving, but nothing dramatic. So this is a point where you probably say, okay, let's stick with case 1, because it gives you pretty much the same result at 2% of the time and less than half of the cost. Now this is, and I'm speaking about this. This is also a session where I would like to have your feedback and your ideas and your thoughts on this, because we're experimenting with this. This is the first kind of iteration. It's the first results of this. There are, of course, limitations. Some more important than others, but this is one you cannot not have a whole group. Right, so it makes sense, right? If you don't have anyone from a certain group, you can't. It's very difficult to build models that models this group. So you can have some cells that are that have few people, but you can't have a whole row, all of them missing people. Another limitation, and this is not just a technical limitation, even though it looks like it. So this is how it looks like when you send data sets to clients, right? So you have the raw data, you attach weights, and they then can use it, analyze it, you can feed it in a dashboard, you can segment it, you can do all these kinds of things. With MRP, after you've built this model, this is not possible anymore to that extent, because it's a model, right? So you don't have the raw numbers anymore. You have digested numbers, or modeled numbers, if you would. And every question has a different model then in the end. So instead of just having one data set, you have multiple data sets. That's one thing. The other thing is actually explaining it to clients. That suddenly, like, here's the data, but there's a model behind it. In some cases, it might be even IP protected, which in that case, you give the numbers and say, I can't even tell you the model, because if I tell you the model, I give away my secret. So they have to believe you. And this can be, they cannot test it. So that's quite tricky to sell in a way. Perhaps I think one of the biggest limitations really, because it takes a lot of education, a lot of explaining, a lot of. I try to now when I prepared the presentation, it was not easy to explain it. So I'm also very curious about your feedback on whether you understood it. If you understood it well, either it says that I explained it well, or that I might have more difficulties than you in understanding it. But really being able to communicate it is going to be a big part of making it usable. The next steps for us, so as I said, this was the first experiment, the first test. The next steps, which are all super, super exciting, is we've run this on a very basic regression model. Right? So we've built a relatively simple model to test it. Now there are logistic regression model. Now there are lots more complex models involving neural networks, involving other kind of multi-level stages that you can apply, and understanding which model works best in what case is tricky. So that might require some machine learning, self-learning algorithms to understand which model works best in that case. Which again doesn't make it easier to explain to clients, but so that's something that we're looking. Then you have the interaction of variables, right? So far we've always pretended that there's a man, there's a woman, there's an age group, and we've always treated them as units that function in and of themselves, right? So maybe there are combinations of this that have more explanatory power than each of the components by themselves, right? So you create joint variables, and you have to test this at a big scale. And then another interesting next step for us is to add new variables to the model, right? One of the nice things is that when you build quotas, it's already difficult, it's already complex, so you don't want to add any more variables to it, because then it either becomes impossible, insanely expensive, the fieldwork, insanely wrong. So in this model, you can add as many as you want. Just throw everything in there and look what happens, right? So this is something that's hugely fascinating. You can start building models based on behavioral data, based on psychographics, based on intentions, and you can all throw this in there and analyze it using these, and not just the typical old age, gender, rule. So it's very, very powerful. It opens up a whole new universe of looking at a population. Some of the applications, perhaps a bit less interesting for this audience, but since we're all in data collection, but what it allows you to do, and this is really where I think it will change the industry quite profoundly, is it makes holding the sample composition stable much, much easier. And this is big. This is very important for any kind of tracking study, right? Anyone who's worked with tracking studies, it's a pain, right? Every time you need these new groups, and it's lots of emails, lots of manual work, lots of pain. Now this way, it's super easy to hold the sample composition stable over time, ex post. You can do niche research much better. So, for example, if you want to look at groups that are very hard to reach, where you might not get a sample size of 1,000 or so, even with a sample size of 50 or 100, you can enhance the data quality. it's always tricky on that small sample sizes to get amazing results, but you can still, just by the power of having a very deep profile and running it through the system, you can get much more value out of smaller sample sizes. And then, for example, in data for market measurement. So in some cases, it really does make a difference whether it's 2%, 4%, 6%, 8% of people who use a certain service, and that's quite common, right? In those cases, the current methods to assess, to get retail data through surveys, which is not a dominant form to get them, certainly the biggest, probably the smallest, but by employing this, you can use surveys to get better measurements of market penetration of certain goods and to measure the market size. So this is it from me. If you have any feedback or questions, you can write to me. We've also written a blog post about this and published it on our website this morning, so you can essentially read through everything I just said, and then also use that to say, amazing, I don't know, sounds weird, here's what you guys could do. So we really want this, I mean, it's an exploration. And we're looking at this, it's fun, we love it, I think there's huge potential. Maybe not in all the areas we'll explore it, but it's something that we feel very passionate about, and if we find something, share it with you and others who are interested. It could have quite big implications. Thank you. Questions, comments?
Are you using it for studies live right now, or you're on test studies?
We are using it for this political risk.
Oh yeah.
And then we just started 2 days ago. We started another. It's the next step. So what happened? I'm from Germany right now. We're based in Berlin, Germany, the company, and Germany hasn't had a government for half a year. And it's a coalition system, so where different parties have to agree on something and then they form a government. Now, the case now is that one of the two parties, so they had an agreement, they have a contract of what they're going to do, so let's form a government. Now, one of the two parties has to ask all its members, which is about 450,000 people. And they have to say, yes, okay, you can go govern. Now, this is a typical case for us. It's very hard. It's like an incidence rate of less than 1% in Germany. It's an older age group, so difficult for us to get through online and mobile in that case. And it's the perfect case for us to test it. So we're doing it now on this to find out. So the actual voting is by post, by mail. So they send out letters, and then everyone who's a member of this party sends the letter back, and then they know the results in 3-4 weeks, right? So what we're now doing is we are collecting information and using this multilevel regression and post-stratification technique to predict the result of this. In most, if they wouldn't say no, it would be a disaster for Germany and Europe. It's a big thing, right? We wouldn't have a government. It's very disastrous. So let's see what happens. The likelihood is high that everyone will say yes. But this is for us a very nice test because it's an event that's going to happen. We can test it. We can see how it works. We can understand all the mistakes we did. We can improve it, and just gets us into.
It's interesting for the percent for you. I mean, even though if you're saying that most people are going to say yes, and it would be probably most people are assuming if they're going to vote yes, but is it going to be 90% or 65?
Exactly.
So
or 50%, and then you can calculate the likelihood. And the case, I mean, now that it's a political thing, which is always nice for us because there's an event that we can test, right? Which is not the case in many of the market research. But in the end, it's exactly the same, right? We have a niche group, a very hard to reach group through classic means. We want to understand how they function. So by doing this, we're learning things that have everyday applications in sampling and the research industry. Any other thoughts or suggestions?
I have a question. I saw you do a presentation in Singapore about Chinese diabetes, which was also another difficult group. And in some senses, what you were explaining there was your method also had some self-learning to make it an easier process. And of course, there were a number of mistakes. The question really is what you're doing now building upon what you were doing then, or is it something completely different? And if so, do you have a number of different sampling, data collection methods that you use alongside this?
It's different. Back then, what the challenge was to find out whether it's doable to do a feasibility, an accurate feasibility, and to find out how best to get these people right, and to understand whether how they function. This is not per se a sampling technique; it's an analytical technique afterwards, right? So they are, and this is it's actually not one; it's a whole body, it's a whole world of regression models that you can apply. Right? You build prediction models essentially. I mean, in the end, this is what it is, right? It builds prediction models for how certain people would answer based on inferences from other data, really, applied to survey research, which is quite exciting, I think. So yeah, we apply lots of different analytical models for different purposes, for weighting, for these kinds of analyses, for predictions, but they are not competing in the sense that you do one or the other. They're more for different types of research, for different applications.
It's hugely exciting to see the reduction in time and cost on the amount of sample purchase. I guess you highlighted the challenge that I can see from commercial application, which is being able to explain to somebody or make them feel comfortable with the fact that you're projecting data rather than collecting it. Part of me thinks it's no different to sampling anyway, because what you're doing now, other than trying to grab something that's representative of a much larger group of people, I'm just sort of spitballing really, to be honest, just trying to think it through, but it's very, very cool.
On your chart where you show the plus or minus 1, how are you calculating that? So that's the MRP as the second chart, you're comparing it to the full sample?
Yeah. So the full sample is our benchmark, right? So, I mean, because we need to have a benchmark. So this is kind of all the cells filled, everything fine.
So is the MRP the same data set? You just cut it in half. You just took the first half of your sample and modeled it, or is that a whole separate study?
No, it's the same data set.
Same data set. Okay.
Same data set. So we ran it, and then we looked at how much could we reduce the time if we knew beforehand what we're doing here, right? So this is kind of first collecting the data and then applying the model. Now what we're doing now is the opposite. Now we're building the model, collecting the data freely, and then checking how good the model was. It's a right. So this was the question we asked ourselves here: is this is very difficult? It takes forever. Can we cut the time? It's what we're doing now with the German political party. It's the exact same technique, but not the goal is not the time reduction, but the predictive power. But mathematically or statistically, it's really the same formula. It's the same thing.
How much resources do you need to have posted tests to do the model?
Say it again?
How much resources do you need to then build this model? Like, if it's just data science team sitting for 3 days,
it's our data science team who works on that. Now this was a first experiment. It's like one of these things, right, where you can do a quick and dirty test, and you can also have a team of 1,000 people work on this. So anything in between, it's like there's no limit, right? Because this can become crazily complex. But we will invest more resources now in this, having seen this, having kind of validated the first, or kind of crossed the first, okay, this actually is exciting and makes sense for us. I also have to be fair. I'm presenting this, but we have a team who has been working on this, Fred and Corby and Jacob. So they also published the post and on this, and I should give credit to them, and also and also some of the deeper questions you have. I do have some econometric and statistical training, but this goes beyond my 10, 15-year-old training now. So I have a gut feeling of what essentially happens, but once you dig deeper, you'd have to ask them on how some of the specifics work, and they're very happy to share. It's one of the things that we do very openly and communicate a lot, because it's something, as I said, that we feel is exciting, but where we also can benefit a lot from the community in getting input and getting thoughts. And not just from the data science community, but from the research. Actually, I mean, this is all about making something better in reality, right? Not just an academic exercise. So having this how we deliver data to the client, all these kinds of things, right, are important for us to understand also and to get feedback on.
With my more intelligent data scientists and stuff as well.
Yeah.
It's very exciting, but I didn't want to know where too much.
Where do you work?
Zappy Store.
Oh, okay.
I didn't talk guys perhaps before, but they would be. We looked at regression models before, a long time ago, but didn't really dig into it in the same way. And I think that these people would be really excited by that stuff. So I'll share all the notes with you.
Absolutely.
Yeah, cool.
I read one of your other blogs about boat. Can you tell us a bit more about that?
We built a boat as a company last year. That I just realized. I mean, are all of you American? I just had a conversation about that over lunch, and there's no tons in the US. Is that true? The metric ton, the unit. What's the next biggest unit after pounds? Tons. Okay. Okay, so maybe Patrick. I was like, it weighs. No, its carrying capacity is 7 tons. He's like, what does that mean? 15,000 pounds? I don't know. Yeah, we built a boat, and whenever any one of you is in Berlin, drop us a line. Over the summer we'll have lots of rides. So it's actually a huge boat. It's made out of wood, and it can carry theoretically up to 60, 70 people, but in reality more like 40 people or so. Otherwise it's like level with the kind of river. It's lots of fun. So do drop us a line when you're in Berlin, and we can have some parties on the boat. Excellent. I let you off then. If you have anything later on, drop us a line, write an email, communicate with us. We're super excited by hearing your thoughts, and let's stay in touch on this. And we also send out updates regularly on where this goes. It's also good because it creates a bit of pressure on us, with these things sometimes where you don't have the immediate business application, you try to kind of lose sight sometimes in your day-to-day work. So it's something that we do really want to push forward, and having also a community where we share and send things helps us stay focused. Beautiful. Thanks a lot.
Thank you.